Welcome back, folks. We'll pick up right where we left off.
So this was really hard to take apart, this engine. It's not designed to be serviceable. I mean, you probably can take out the spark plug and put in a new spark plug, or replace the filter on the carburetor, but I think that's pretty much it. The internals of the engine are done in such a way that you cannot take this apart and then put it back together and hope that it still runs. Little sidetrack here, interesting. The cylinder head is cast aluminum. Okay, so I think that's how it sits now. Yeah, that's how it sits. So there's a gasket, but this is cast aluminum, and the sump is plastic. And this is really interesting. You know, some of you might ask, how could that be? And if you think about it, most of the heat is going to be right here at the head. So the heat is being generated in a combustion chamber. And so the further you go from the combustion chamber, the cooler it gets. That's why they put all these fins here, so they can properly cool it and not overcool it. If you overcool an engine, that's also bad for the engine. But a lot of that heat travels through the exhaust pipe and then into this little silencer. Okay, so the silencer rests right there. And that's why you cannot make this out of plastic, because that thermal aspect. But what I wanted to show you just moments ago is the crank mechanism. So the crank mechanism consists of the main spindle, okay, and you can see that on the spindle we have a gear here, okay. So this is not really a gear, this is a pulley. So I'm gonna find it. There's a belt right there, okay, and this is the camshaft shaft, and so you can see that the ratio between them is 2:1. So this is 2 and this is 1. Okay, the number of teeth on it, I can count it, 17. I think it's 17. So this one should be 34. Okay, so there are the two shafts. And this guy sits in a housing like so. Okay, and then you have the crank cheek, and that's the crank cheek, and that 1/2 of the crankshaft. Basically, usual engines, they usually have 2 of them, so they have one on the right, one on the left, but this guy only has 1. And the way it's put together, this is press fit, so it's either this is heated up and this is cooled down, but I think what they do is they just rest this end and they just press this on with a press when they're doing the assembly. So it sits in that bore right there. And if you want to take it apart, if you want to take the piston out, first you have to press this shaft out, because otherwise she will not come apart. And if you don't do it, if you don't press this out, there's no way to disassemble the piston. So there's the connecting rod, and there's a little bearing here. So this is just a little needle bearing, and that holds the connecting rod. And you can see discoloration on the connecting rod. You can see the upper portion, and then the lower portion are discolored. If you look carefully, there's a change in sheen. So what they do is they heat treat this, and they're gonna grind this and this hole on some kind of grinding machine, grinder, internal grinder, and then they can press fit this bearing in. These needle bearings are also really interesting. So they don't have a beefy housing. The case, the race, basically the outer race, is paper thin. So the needle bearing manufacturers rely on the other parts to provide proper stiffness for their bearings. So that's why, you know, this guy has a little bit of meat here. So when this is press fit, it's actually holding those needles back. It resists. A couple more things. I probably need to zoom in. So this is a rocker arm. Okay, so size-wise, we are looking at 37 millimeters length. So that's a little over 1.5 inches. 1.25 inches. Let's say 1.5. Yeah, it's around 1.5 inches. And this is the valve. Okay, so the length of the valve is about, again, 1.5 inches. Look at that, I can just switch, it's that smart. And the size of the valve stem is basically 3.5 millimeters. It's a little over 1/8 of an inch. A couple more parts here. So these are the valves. Okay, so I'm gonna just lay them out like so. These are the valve springs, and then these are the locks for the valve springs, and these are the rocker arms. Okay, so there's one rocker arm and there's the other one. And if you don't know which valve is which, you can usually look at the size. Okay, and then the bigger one is the intake and the smaller one is the exhaust. Now this is the bigger one. It's got a marking on it. Sorry about that, that's my first video. I'm trying to focus and have enough light. So you can see there's a marking, it says I. So that's intake. And then the exhaust also has a letter E, but you can't really see because of the shmoo on it. So it's got the burnt on oil. And I need to correct myself, I didn't realize, but these are the actual valve seals. So you can see that it has a seal on the valve. So this is just a piece, some kind of slinger that houses the seal, and it will be pressed onto the housing. The spring is going to press this against the housing, and so that's how they seal it. I didn't remember that. Again, I took this apart, 7 years ago, and that's just the seal. It doesn't look like that it has a spring on it. And so this is, again, that's the exhaust, this is the intake, this is the exhaust. And the springs, the valve springs, there's no marking on it. It looks like they are the same. When it comes to the springs, the important things are the length of the spring, the number of turns of the coil, active turns, what we call active turns, and the size of the actual coil, okay, the material that they made it out of. So these valve springs, the coil is 1.3 millimeters, the total length is around 17, and this guy This guy has 1, 2, 3, 4, 5 turns. So two of them are not active, the bottom and the top one. So it really only has 3 turns. So it goes like so. Okay. And then this guy basically just goes through like that and slides on. And there's your valve with the spring and the top dish or washer, whatever it's called. But there's no traditional lock like other valves have 2 halves. This one doesn't have one. I'm just going to put it together and make sure that I have the parts properly sorted out. So this is being the exhaust, and then this is the intake, so all the parts are together. So these are the rocker arms. So that's one of the rocker arms, and here's the other one. It's attached to a post, and so it's rocking on that bolt back and forth like so. Okay. Bolt is actually stationary, and then the rocker arm is rocking on it. And these are just sheet metal. What they do is they use some medium carbon steel. They're gonna heat treat the heck out of it and maybe finish something on it, but this doesn't look like anything is finished on it. It's got these little guides on the 2 sides, and they serve a purpose so that the valve will rest between those guides, so it's not able to slip off of it. Every time, if you look at any part, it consists of features. So the part is built out of features, and every feature has some kind of purpose. They don't just slap features on it. Everything has a purpose. So it's either technical, you need it for the part to operate properly. It can be manufacturing, like we have a tiny radius here. Okay, that radius goes along, and then you have the big radius on the outside. Well, this is manufacturing. When they are bending and shaping this into shape, you know, obviously they start from some kind of flat disc or flat pattern, and they're going to shape into this shape with dies, and so that creates a sharp corner here. And if the die is really sharp, you will start hitting that die, will start to break. And so you want the die to live long, and so you put a little radius on it to begin with. And so that's what this radius is. So every feature you see on it has a purpose. Like you can see, they cut this part partially out, and then they just created this flange out of that material that they cut out from there. So finally we got to the part that caused me to buy this thing for 20 bucks, I guess. I don't know if you guys can guess what this part is. If you had one of these, or you read about it, you know what this is. Yeah, this is the camshaft. So that's your camshaft. For the ones not familiar with the field, you know that camshafts are made out of steel. And it's just not the steel that they make hoes and spades and shovels out of, but some good grade steel. And it usually is heat treated, it's got hardened surfaces, and then it's ground. And it's really a precision part. And what you see here is everything but precision. So there's some markings on it. So right here it says PA46. Again, that's polyamide, that's nylon. it doesn't have glass fiber reinforcement. It doesn't say that has glass fiber, and I'm cutting chunks off and it doesn't have a sound. On the other hand, if I'm cutting that, you can clearly hear that this part has glass fiber in it, but the camshaft doesn't. So this is a drive for the camshaft, and it's got a flat on it, and that flat is going to interface with the flat inside this guy. So when I press it together, it will make one part. I don't want to press it together because then it will be hard to take it apart. But what you can see here is it's got a flange. I think this is called a slinger, and it prevents the oil from coming out. And this camshaft basically sits right there. Okay. And as I remember, there was one more part here. Okay. So this is some kind of a boot. So this is the drive side, and this is the non-drive side of the camshaft. And this boot was attached to this side. And so I assume that a certain amount of oil is being pumped here or being pumped out of here. Or this might just be, I think this was attached to the carburetor. So here's the carburetor. It's got a couple extra ports on it here. I don't quite remember. I have pictures and I can look that up. But the thing is that the person who sold this to me said it doesn't run. I took it apart, and then it became obvious that one of the lobes on the camshaft is completely melted. And so this happened to be the same side where the exhaust port is. So this is the exhaust port. You can see the black charred residue inside, and this is the inlet here. So inlet and exhaust. And this is the exhaust side. So what happened is the exhaust side got really hot, and this rocker arm basically like that. So the rocker arm is touching on the camshaft, and we had heat transfer. Maybe the valve clearance wasn't set properly, so there was excessive friction. Maybe there was no oil in it, and it had excessive friction, and so it completely melted it. So if you have one of these, you might want to pop the cover off and do a feeler gauge and see if you have clearance there. And otherwise, just make sure that it has plenty of oil and that it has proper cooling. One more thing could be that because this works outside, some debris can be sucked in by the fan, and then it will plug up some of these ribs inside, and then that can overheat the engine, which will ultimately lead to the demise of the camshaft. I'm planning to have a future video where we might be able to go and scan the camshaft, at least scan the intake side, and then come up with the geometry. And those who wants to fix theirs, machine a part from aluminum maybe, or maybe steel, to have a blueprint to go from. But I assume that the intake side and the exhaust side cams are identical. There's still a little bit left of the exhaust side cam, so that would basically give us some clues as far as valve opening, timing. Here's how the parts go together. So that's the main housing. We got the camshaft drive shaft. This is the crankshaft. and then this belt is going to go into this groove. Okay, goes in the groove, and like so. And what's not cool about it, that if the belt croaks, you got to take apart the entire thing. I'm sorry, I swapped it over. It actually goes like so, and then this goes from this side. Okay, so you got a flange here. You got a flange right there. Okay, so that flange, I think, prevents you from installing a new belt. Although it might be possible through this gap here. I think if they smart about it, you might have a fighting chance to install a new belt through this gap when this is sitting there. But remember, there's a bearing on this side. So first you have to remove the bearing with a really strong magnet or just simple willpower, and then you can install the new belt, and then you have to press in the bearing again. And so what we got here is this guy. You know, this is basically the magneto and the fan all together. So you have the magnets here. So this is just you know, creating the power for the sparks. And this is tapered, so it's all cast and tapered, and it's got the key built in. So that will sit over this taper here. So the shaft has a taper. So this has to come off. And then when you want to put it together, you need to make sure that this is aligned properly, you know, so you are top dead center. And then once you top dead center, then this hole right there on a cam drive has to be aligned to some kind of marking. I don't know, it probably has a mark on the housing or on the shroud, on something. But it has to be clocked properly, because otherwise, you know, the valves and the piston not going to have a proper clocking. So I'm afraid if this belt goes belly up, then the whole thing has to come apart. So you have to press this out from the crank cheek. I mean, you are looking for a 4 or 5 hour work for someone who done this before, and that's probably $100-200. And what I saw, you can actually buy these engines, the whole engine, for like $50 on some of these websites. Some people online were talking about the belt is running off of this plastic timing pulley, and most of the people complain about the carburetor. You know, the last 20 years they started put a lot of ethanol in the gas, and so that eats through the carburetor. What you do is you take this apart, blow it out with a pump and clean it, and then put it back together. Try to put it back together the way it was, and then you know, have a fighting chance. Okay, so all the parts we reviewed is basically the engine housing, cylinder, and cylinder head assembly. This is the flywheel, magneto, impeller, depends what you ask. This is the crank housing cover. Here's the shroud. Again, the name and the part number. Here's another piece of shroud. Those are all the parts for the crank and the valve train. Some more shrouding. Ow, almost forgot. There's the piston and the rings. So this is the middle ring. Here's the oil ring, and then this is the top ring, and this is the piston. Okay, piston has some markings on it because I was doing some measurements. The diameter is 35.4 millimeters and the length is 26. So this is probably metric. Most of the components on it were metric, the fasteners. This is the magneto. So the impeller passes by the magneto. You can see that it's magnetic. These are permanent magnets here. So these permanent magnets flying by the magneto. This is the lamination. So you can see it's made of thin steel lamination. They want to decrease the iron losses. It looks to be about 1 millimeter thick, so it's really cheap. And then this guy here has a coil. Yeah, and so it's got a primary and a secondary coil. So this one is the secondary coil. That's what gives you the high voltage. This is the ground. So the lamination is the ground for the secondary coil. And then this boot is attached to the spark plug. And this is the primary coil. So the primary coil has one lead here. It's got one lead there. I believe if you connect this to ground, this terminal, that kills the engine. So that's what the kill switch does. But I might be wrong. I've been wrong before. That's the gasket for the crank housing. Here's the cover. Basically tells you how to start it. Prime, set, pull. Wait 6 to 10 seconds, squeeze trigger to run. And then use the stop button, switch to stop. There's a stop button here somewhere. This is just a shroud for the carburetor. There's a mesh here, really coarse mesh, so I'm just supposed to stop some of the debris that would otherwise enter the engine. This is just a spacer for the carburetor, plastic spacer. I'm guessing that they are using a usual carburetor that's out on the market and it doesn't fit well, and they just use a spacer, makes it cheap. Remember this guy, this is a seal. So this was a seal for the camshaft. Okay, so it sits right there, and I didn't busted it. It was like that. So it was halfway tuned through. You can see the wear on it. And then this guy, let me zoom on it. Learning this YouTube thing, so be patient with me, please. Okay. There you go. Maybe a little less zoom. Okay. So you can see this hole here is not cylindrical, but it's oval, and there's a lot of wear on this side. So the belt is pulling in this direction. So when the engine is cranking, one side of the belt is pulling in this direction, and that's where the wear is. So the shaft is the camshaft shaft is just running on this aluminum, and there's nothing, there's no bushing on it, nothing. It just runs on the aluminum, and you can see that there's no like a bronze bushing or something, anything. So it wore through there. I can actually try to get the camshaft and goes in like so, and it's wallowed out. So even without the flat on the shaft, even without the flat on the shaft, it's got quite the run out. So I can imagine this engine was running without oil, or the oil didn't get up here to the top for whatever reason. And so that's why it's wallowed out. And that wear basically wore out the seal also. So here's the seal. And you can see it's damaged. Gas tank, okay, it still has gas in it. Right there, sorry. Gas tank still has gas in it. You can see it's got usually two pipes, so one is for intake and the other one is being pressurized by the engine, so that it will pick up the gas. And then this is the muffler. So here's the muffler, a little bitty muffler. Carburetor, this is just a heat shield. It's made out of some kind of pressed, stamped, corrugated something, and then there's some aluminum foil here. Looks like the same aluminum foil they use on the H-racks. I'm not sure what extra protection that gives. These are all the fasteners. You can see a lot of them are threaded fasteners. And then there's also plenty of these self-cutting, self-piercing fasteners for plastics. Throttle body. Okay, so there's the throttle. So you're actually yanking on this cable, and then the other side of the cable is adjusting the carburetor. This is the there's another seal. That's probably from the other side, and this is in good shape. So this is the starter body, and it's missing the wire because I already used the wire for something else. I just cannibalize these parts whenever I can, wherever I need some other parts. And that's basically it. This is just a spacer for the crankshaft. And then this is just the manifold that connects the non-drive side to the carburetor. So I think that the pulsating vacuum or air or pressure, whatever we have inside the engine, they use that for something in the carburetor. This is supposed to have 3 ports, but it only has 2 ports. So those 2 ports go to the gas tank. So this is really an enigma where this guy might go. I know it doesn't go to these 2 because that's where this one-way valve was sitting. There's probably another port somewhere. So I'm gonna stop right there. If you have any questions or comments, or you're interested about some of the other parts or dimensions, leave me a comment in the comment section. Otherwise, thanks for watching. Come back next time and see you guys. Bye.